Yellow on a journey to find to solve matrix equations that involve multiplication. So, big lesson today is to find the inverse of a matrix using the determinant. Actually, before we get going any further, I have some subscribers out there looking to pump up our channel a little bit. Like it or subscribe to it. We're going to take all proceeds and they're going to go to a classroom pet. I don't know if it's going to be a goat, a cat, maybe a rodent of some sort. But yeah, we'll take proceeds that for subscribers and all the lucrative commercial contracts and incentives for advertising that we get here, and it'll go straight to a pet. So anyways, just want to get a plug in there for us. So we're on that journey. I want to show you guys what our ultimate goal is, and this is going to happen tomorrow. And before we get there, I got one more thing to talk about. If these are matrices, A, X, and B are matrices, and we want to solve for this, the way we solve for this is we find the inverse. We don't have divided by A. We can't divide by a matrix. So we find the inverse of matrix A, and we multiply both sides by that inverse. Now, the order we do that in is going to be important, but what essentially is going to happen is the inverse of A times A, that's going to cross out, and we will be left with matrix X on this side, and then we just have to compute the product of the inverse of matrix A times B. So, in order to get there, we need to know how to find the inverse. In order to find the inverse, we need to know how to find a determinant. And so that's where all these lessons are linked. Big idea today, we're finding the inverse of a matrix. So first thing is this. We use the inverse of a matrix to solve. That's what I just talked about. This is the actual formula in red here. In black here is any 2 by 2 matrix. And by the way, we're just going to do that for 2 by 2 matrices here in this unit. So to find the inverse of this, we have to first find the determinant, is what we learned yesterday. We make that into a fraction, 1 over the determinant. Remember, the determinant is the product of the diagonals, and then we subtract them. So 1 over that goes out in front, and that's the scalar that we multiply an altered version of this matrix. You can see what's happening here is upper left and lower right elements switch. Lower left and upper right elements stay in the same spot. They just turn to opposites. And then we simplify that, so we just do a scalar on that. All right, so I'm going to do 2 examples with you guys today. And the first example looks like this. We're just going to go and find the inverse of this matrix. All right, so let me get this up here. Let's get rid of this action, and let's do it. So first thing we're going to do is we're going to find the determinant of matrix A. In this case, we're going to find the determinant of matrix B. All right, it was labeled B. So we take the product of -5 and -3, and we subtract that from the product of the other diagonals. All right, so this is 15 minus 14, double negative. So this would be 29. So that's the determinant. So the other thing we're going to do to find the inverse of this matrix, we're going to take 1 over the determinant, and we're going to multiply that by an altered form of this matrix right here. All right, so the first thing I would tell you guys to do is basically switch these diagonals. So -3 is going to be upper left, -5 is going to be lower right. And then the other diagonals, we're just going to change the sign of them. So that's going to be minus, and that's going to be a positive. One last step here, so that's listed. We can use this form, and then all we're going to do is there's just going to be a scalar here. So we're going to multiply all these by 1 over 29. So we'll do a little bit of math. Maybe we can simplify later if we need to. So when I'm multiplying these, you guys, remember when I'm multiplying fractions, 1 over 29 times each of these, I multiply, if I'm taking a fraction, I'll just do it off the side here. 1 over 29 times 2. So basically, I'm going to multiply turn this into a fraction, these top two numbers, that's going to be 2. And then multiply the bottom two numbers, it's going to be 29, and then simplify that if I can. If I can't, that's my final answer right here. Boom. That's how we find the inverse matrix using the determinant. So let's just do one more example here. Notice on this example, I have if it exists. So I want to show you this problem that we have here. First step is we're going to find the determinant. I always like to write that down right away. So I take the product of -4 and -3, and then I subtract 2 and 6. Right? So this is +12 minus +12, which is 0. Now, as I'm going through this formula, the first thing is it's 1 over the determinant. And then I'm going to do my little matrix switch here. -3 and -4, those switch spots. 6 and 2 become opposites, but they stay in the same location. Now, before I get going any further, hopefully you have some danger alerts going on. This is an issue. All right, we know that it's not defined divided by 0. So here's a situation where there are some matrices that do not have inverses. And this is an example. This matrix in this problem does not exist. And the reason why it does not exist is right here. If the determinant, so if determinant equals 0, then no inverse. All right. Other than that, we find our inverses just like I told you on that previous problem. A little bit of practice. We put it all together tomorrow, and then we're done with matrices. So let me know if you guys need help. Take a look at hopping on the Google Meets. Otherwise, until next time, you guys stay clean, wash your hands, disinfect your phones, and most importantly, be kind.